All right, so this is the homework 3.2 help video. As with every homework help video, I hope that you'll pause the video, read the question, make sure you're understanding what's going on in each of the questions before you just look at the solution, maybe give it a try on your own. But I'm going to go ahead and hop into it now. All right, this problem gives us kind of a strange context. We're talking about fingernail growth. We're given how long a fingernail is initially, and then we're told how fast it grows per month. Now, one of the most important things we can do here is identify the meaning of the variables. We've got length L, and then we've got, let's see here, the input variable, which is time, T, months. Okay, that's the measurement in months. So what we need to do is figure out how can we model the relationship of the length of a fingernail after a certain number of months have passed. Well, we need to look at sort of the initial setup of the problem with the context and see if there's any information given there. We're told that nails grow at an average rate of 3 millimeters every month per 1 month. Okay, I'm looking at this and instantly I'm seeing some sort of ratio. You can see that because it's a ratio of length to time. I can write that as length over time, L over T, right? More specifically, it changes, the length changes by 3 millimeters as time changes by 1 month. The change in our function value divided by the change in the input variable, this is called the slope. This is the slope of the line that will model this growth situation. Now, just like in class, I can't just have one bit of information. It's not enough for me to come up with the formula for this model. I need a second piece of information. We look back at the context. If a nail is initially 13 millimeters long, ... find this formula. Okay, there's more information than meets the eye here because we've got a length is equal to 13 millimeters initially, which means no time has passed, 0 months have passed. So what we actually have is a point, input variable, comma, function value, that has the coordinates 0, 13. Now, we've gone over how to come up with the equation of a line given an initial point and the slope. You're going to be using your y equals mx plus b form, and your job is to substitute in what you know about slope and substitute in what you know about b. Okay, in this case, our first bit of information that we have is all about the slope. Y is equal to 3 millimeters per month times x plus b. Now notice I've changed everything over to y and x. My brain just does that naturally because I know if I have to use the calculator, my function variable becomes y in the calculator, and my input variable will become x in the calculator, okay? But for this WebAssign assignment, y is L, right, that's my function. So L right now is equal to 3 times t plus b. Right, just to use the variables that were given in the context, L and T. Now remember that if you have the initial value, you know when T equals 0, Y equals 13, L equals 13. That tells me the B value right away. B there is going to be 13. We're going to be adding 13 at the end of our formula where that B was. So L is equal to 3T plus 13. Another way that you could have gotten that bit of information would be to substitute in 0 for T, 13 for L, that's in this equation, and then you would just be solving for B. You could figure out what your B value was that way. We did an example like that in class. Okay, you can reference that if you want to try that other method. Okay, let's move on to the next question. I'm going to work this problem from a sort of tabular approach, but of course you can refer to our notes if you want to do it the faster way. I just want to make sure that you've had some practice with these other skills, like approaching these problems from different directions. So with this problem, we have an elementary school taking a busload of children to a science fair. it costs a certain amount of money just to get the bus there and back. And then there's a sort of admission fee for each student. This is like if you wanted to buy a ticket for each student to be able to get into the science fair once they get there. You can notice I made a little table off to the side on the right. The first column has N, which if you were to read part A, you would see N is the number of children. That's where I'm getting these variables from. And C is in my second column. It's going to be the bus cost plus the admission costs. Okay. There's a flat fee going on with this bus. No matter how many kids I take, I still have to pay $140 plus whatever it costs to get these kids into the science fair. So for C, I'm going to be doing with 0 children, I still have to pay the $140. That's an empty bus that I'm sending to the science fair. I still owe $140. But I don't owe anything for admission because there were no students on this bus trying to get into the science fair. When one student gets on this bus to go to the science fair, I still have to pay the total fee for the bus, which is $140 in my problem. The number might be different in yours. But now I have to add on the ticket for this one kid. That's $2 per kid times one kid. When 2 students get on the bus to go to the science fair, I have to pay the $140 bus fee, the same as in every scenario. This is a flat fee. It doesn't change no matter who's on the bus. $140 for the bus. Now I have to pay $2 per student times 2 students. That's $4 in admission fees. Notice I'm not simplifying the data that's in the table. I'm trying to get a formula to pop out. That's the whole point of part A. Okay. When 3 students get onto the bus, I have the $140 flat fee for the bus. And now I'm paying $2 per student, but now I have 3 students. That's $6 in admission costs. You can see this cost starts rising very slowly, $2 per student, per additional student. Now, as you start to look at these structures, you notice that all the way down this table, 140 has been a constant value being added to some other value. Now, notice that I have 2 times the number of students, 2 times the number of students in each of these rows of the table. Therefore, in my final row, when I don't know how many students I have N students, I'm going to be taking 2 and multiplying it by N instead of some number in the parentheses as before. So what this does is it gives us a formula for C. So for me, using my numbers with 140 and $2, C would be equal to 140 plus 2 times N from our table. Okay, 140 plus 2 times N. Now, when you start to look at part B, it's asking us for very specific information. It says identify the slope and the initial value of C. So we're looking at the function C, and we're trying to determine some critical information about it. Now, a couple ways to go about this. You know the general form of a line, y equals mx plus b. This is our slope-intercept. You can identify the slope immediately from the formula as the coefficient or the number in front of your input variable. In this case, that would be a 2. It's being multiplied by n, the number of children. That's our input variable. The initial value is the term that's all by itself over here being added to some value of n. So we have mx, or in our case 2n, plus b, or in our case 140. So you could type those in for part B, or you could utilize the context. Okay, identify your flat fee, this value that does not depend on the number of students. It's that 140. So back in our table, even when 0 students join us at the science fair, I still owe $140. This is an initial cost. It's an initial value. The slope here, it can be determined in the context as the price per each student's admission fee, because that value is multiplied by the number of students that join us. It's a per student fee, so it's actually considered the slope of the formula. Now, I love WebAssign because it'll take these questions even further. After you've identified the numerical values of slope, and the initial cost, it says to explain to me in practical terms what that means. The slope indicates that for each additional child that we take on the trip, the cost is going to increase by $2. Those are my numbers from my WebAssign problems. The initial value is, I believe we answered $140, and it is the cost of taking the bus itself to the fair. That's when you have no students on the bus. You still owe $140. Okay, so let's continue on with this one. I chose this problem because it had so many parts, and I think that each of these parts will, when explained, help you to solve the rest of the homework assignment. All right, we already did this top piece. We did that on the last screen. We're moving into part C now. We need to explain in practical terms what C of 15 means. Well, let's look back at our formula. C of n is equal to 140 plus 2 times n. And again, those are using my numbers. Your equation might have different numbers in it, but it should have the same form. Okay. C of 15, let's write that right below it. We can sort of get a parallel here. C of 15, it says that the input variable is 15. So what your job is now is to determine when n equals 15, what is C? C of 15. What does that equal? Okay. So C of 15 itself, don't get confused in this. It's not the number of children for 15 children. While n is 15, C of 15 represents the total cost of the science fair trip if 15 students make the trip. If all it said was n equals 15, that would be the number of children going on the trip. But because we have C of 15, when 15 students go on the trip, what's our total cost? It becomes a cost scenario. To calculate C of 15 in the next part, all you're doing is substituting in. You can go back up here to the formula. You're substituting in 15 wherever you see an n. So right next to the 2 is where our 15 is going to go here. Okay, and I'll leave that math to you. It looks like it's going to be about 170 for my numbers. Okay, but you're just substituting that value in. Now, in part D, they're trying to kind of reverse the roles of these variables here. A lot of people got this wrong on the in-class quiz, so pay attention to what they're really asking here. Solve the equation C of n equals 156 for n. That means, and look at the way the answer is set up, it's an n equals some number. N equals some number, which means we're going to take our original equation, which is C equals 140 plus 2 times n, and we're going to solve this equation for n. We know that C of n, or C, is equal to 156, which equals 140 plus 2 times n. The only variable left in the whole equation is n, so it makes sense that we're trying to solve for n. All right, we've practiced solving linear equations quite a bit, so I'll just do this very briefly. We're going to subtract 140 from both sides. Okay, we're going to be left with 16 equals 2 times n. 2 is being multiplied by n, so we're going to do the opposite operation to get n by itself. We're going to divide both sides by 2, and therefore 8 is equal to n. So when 8 students get on the bus to go to the science fair, the total cost is $156. Right. So based on the work that we just did for part B, you should be able to answer this last question. The solution of the equation 2n plus 40 equals 156. We just did that. We just talked about it. Is the number of students we can take if there's how much money to spend. Well, we were told that. We were told that right away. We were told that the cost for n students equals $156. Okay? This is about reading comprehension, being able to determine which variables represent which quantities knowing that N represents the children and C of N represents the cost for a certain number of children. Okay, that's going to help you identify which numbers are going in these answer boxes. This question, number 5 here, is a lot longer. It's one reason that I chose it. It's also because you're given different information. You're not given a slope in this problem. You're given multiple points, non-initial points. So what I want you to do is make sure that you understand the context before we start part A, because there are a lot of pieces that are going around in this problem. All right, so as part A dictates, we are trying to determine a formula that expresses the net income as a function of the total sales in dollars. This should look like N of S. The net income is a function of the sales in dollars. This makes sense. How much are you going to walk away with at the end of the month in your pocket, your net income, after you've made a certain number of sales, right? So they've kind of combined this idea of revenue and cost, and they jumped straight to, if I sell S dollars of merchandise, I'm going to take home this net income, capital N. Okay, and our job is to come up with what that formula is. All right, so I went ahead and pulled out a couple of important bits of information that I thought would help me solve this problem. What I first needed to identify is that N is a function of S. So any data points that I have will have this form. Input variable S, comma, output variable N. So S, comma, N. So my sales will be in the traditional X position, and the N will be in the traditional Y position. Right? So when I'm reading through my scenario, I'm trying to find different S and N pairs. The first thing we come across is, in July, the agency had a total sales, that's a little s, of $832. That gave them a net income of $15,704. I went ahead and made that into an SN point, 832,000, comma, 15,704. In August, that's the next month, the total sales were a lot less, $326,000, with a net income of only $523. So this net income and the sales, they're varying quite a bit. But our job is just to distill that information into two different points, 326,000, comma, 523. Okay. You can see that I've also pulled in this equation here. This should look like a slope to you. M equals the change in our function, delta N, divided by the change in our input variable, which is delta S. So just filling in this formula for slope, we're going to be doing N2 minus N1, 0, 4, over S2, 326,000, minus S1. This is our formula. This is how you calculate the slope given 2 points. So if you were to put this into your calculator, 523 minus 15,704, maybe put that in parentheses. Divide it by another set of parentheses, 326,000 minus 832,000. According to my calculator, I'm getting a value, get my pen up here, I'm getting a value of about, I need to kind of make these a little curly because it's not an exact value, 0.03. Now the number that I'm actually seeing on my calculator is 0.03000. Okay, so it's pretty safe to estimate it at 0.03. Also, the problem tells us round your answer to 2 decimal places. So for me, the slope here is 0.03. Now let's look at the vertical intercept. This is some work that we did towards the end of class, talking about chapter 3.2. You know that the formula of a linear equation is y equals mx plus b. You now know what m is equal to, 0.03. So I substitute that value in. Okay, I'm using y and x here for ease of calculator usage if you want to go see what this is in your calculator. But you should recall that what our real formula is going to look like is n of s is equal to ms plus b. Okay, just having those proper variables there, where n is like y, s is like x. Okay. Now towards the end of class, we said, well, I need the slope and I need an initial point, but if I don't have that, it's okay. I can use any point I want along that line. It'll still give me the same line. So my n value or my y value is 15,704 when my input variable is equal to 832,000. Big numbers here, but it doesn't change the procedure at all. So what you're going to do is multiply 0.03 by 832. You're going to get about 24,960 plus b is equal to 15,704. Now we're just trying to solve this equation for b. We're just trying to find that initial value, that b value. So what we need to do is subtract now. I'm kind of running out of room here at the bottom, but we're going to subtract 24,960 from both sides, minus 24,960 from both sides. Now that's giving me a b value. I'm just going to try to get it right in this corner here. B is equal to negative $9,256. So now I can come back up here and I can fix my equation. N of S is equal to, I knew my M value was 0.03 multiplied by my input variable S, but B, I'm subtracting off 9,256. So let's go ahead and turn that into a vertical intercept. Vertical intercepts have the form 0, comma, initial value. B is that initial value, negative $9,256. Now let's talk about part C, because it's highly related to the work that we just did. What are the real estate agency's fixed monthly costs? These are costs that do not depend on the number of dollars in sales that we do. It has nothing to do with our input variable. Okay, it's only this constant flat rate every month. So if you just look at your equation for N, you can see right away that the only quantity that's not incorporated with S at all in that equation is this negative $9,256. That is our fixed monthly cost. $9,256 here, just using my numbers. Your answers might be different depending on the numbers you were given. Now it's asking us, what percentage commission does the agency take on the sale of the home? Rounded 2 decimal places. This is part D. And I know that I had to go back and read the context. What do you mean percentage commission? Where did this even come from? Well, the first sentence and the second sentence kind of set us up to understand this. A real estate agency has fixed monthly costs. Okay, we've already talked about that, $9,256 a month. Second sentence, it earns its money by taking a percentage commission on total real estate sales. So any of this money earned, this net income, okay, this in value, it deals with a percentage of the sales. So what we're doing is we're taking our slope, right, which we calculated over here. We're taking that slope and we're going to write it as a percent, as a percentage commission. 0.03 is equal to 3/100ths. 3/100ths. Okay, that's just writing the decimal as a fraction. Now, turning this into a percentage means per 100. So what we have is 3 per 100. That's 3%. So our answer here will be 3.00. Okay. Now, when you were calculating your slope, if you had a lot of decimals out here beyond the second decimal place, maybe keep those on hand in case you need to use those here in part D. All right, part E is finding the horizontal intercept. We've been doing this for a little while. You learn to use your calculator. you enter in your equation into y equals, for me, that's going to look like y1 equals 0.03x minus 9,256. For the graphing portion of this question, you would also need to be able to put this into your graphing calculator. Okay, so maybe it's already in there. But here's your y1, and what you do is you press graph. So you're going to go look at your graph. Do you see your your x-intercept, your horizontal intercept on the graph? If not, you need to go modify your window until you can see where your function crosses the horizontal axis. Once you adjust that window, you're going to use your calculation menu, which is a combination of buttons. Second trace, that's going to bring you to your calculation menu. From the calculation menu, I want you to select 0, right? A 0 is just another name for horizontal intercept. This is the graphical approach. This is letting the calculator do the work for you. And I'm going to show you the other method for solving this problem now. All right, so you can see I cleaned up the workspace and I wrote out what n is equal to. This is the formula that we've been kind of working on throughout this problem. It's what you would have entered into your calculator just a second ago, but using n and s now. When you're looking for a horizontal intercept, what you're really looking for is when your function value is equal to 0. So we're going to substitute in. When is n equal to 0? Well, I don't know yet. I need to figure out what s value causes my net income to be 0. So in context, I'm trying to determine when I sell S number of dollars, unknown at this point, I walk away with no money, but I don't owe anyone any money either. This is when net income is equal to $0. So the first thing we can do to get started, we're solving for S. We're zeroing in on this S here, this S value. So I want to start doing the opposite operation of what I see. This is solving linear equations. I'm going to add 9,256 to both sides. 9,256 to both sides, like I mentioned earlier, and your numbers might be different. So now I have 9,256 is equal to 0.03s. Even though this is a decimal, we treat it just like any other number. It's being multiplied by s. We have to do the opposite operation. In order to get s by itself, you must do it to both sides. Divide both sides by the same value. So my right-hand side of the equation simplifies down to s, while my left-hand side of the equation simplifies. I'm doing 9,256 divided by 0.03. And wow, you get some big whopping number out of here. $308,533.33. I'm rounding out to the penny here. So that's 2 decimal places as hinted by in the question part E. Okay, so this is the number of dollars in sales I have to do in order to walk away with no money in my pocket and not owing anyone a single dollar. Net income equals 0 when I sell $308,533.33. All right, so last problem of the video. I chose this one because it uses all functional notation and there's no indication of any sort of context or meaning behind the variables here. So I just wanted to do this very basic example of how function notation plays into calculating slope. All right, it's no more difficult. In fact, some of you might find it easier than using context because it's pretty straightforward. We know that f is a function, tells us right away. F is a linear function such that f of 3 equals 4 and f of 6 equals 19. What's the slope of our function f? Let's say that f is a function of x. F is a function of x. So if I want to calculate the slope of that function, I would be doing here, let me write the whole formula out. The change in our function values divided by the change in our independent variable, our input variable, which in this case, I'm calling it x. Okay. We weren't told what that input variable is. I don't know what it's called. I'm making this up. You could call it Charlene if you wanted to. So my slope now, I need to determine what's the change in f. It might be easier for you to read this problem as points. I've got f of 3, so I'm going to have points of the form x comma f. Okay. When my input variable is 3, my output variable is 4. When my input variable is 6, my output variable is 19. That's how the function notation translates into coordinate points that we can use in the slope formula. So what I'm going to do is function value 2 minus function value 1. That's, for me, in my numbers, 19 minus 4. Divided by 6 minus 3, the difference in my x values, my input variables. Right? So I got 19 minus 4 is 15, that's the top. 19 minus 4 is 15. And 6 minus 3, well, that still gives me 3. So it looks like this one's going to be kind of nice. It's going to simplify down to a whole number. It doesn't always work out that way, and that's okay. The slope can take on many forms: decimals, fractions, whole numbers. And in this case, I got a nice number of 5. So no matter what numbers you're presented with, no matter whether you're given some sort of complicated context or just functional notation or just points in general, you can still use this slope equation just the same. Just figure out what are your function values versus what are your input variables. And that should take you through most, if not all, of the concepts behind the homework for 3.2.